The reason I've spent some time looking at how hash codes are used in some collections is because it is this that leads to the strong connection between hash codes and equality. To understand this connection, think about our dictionary example again, in which lowercase apple is stored in the last bucket. Let's assume some code tries to evaluate this expression, mydict square brackets apple, which has the effect of looking up the key apple. But notice the capital A. We follow the same procedure, call getHashCode and divide by 5 and take the remainder. And this time you get the answer 2. Well, that bucket's empty, which tells us that the key apple with a capital A is not in the dictionary. Notice how apple with a capital A gives a different hash code and leads us to a different bucket from apple with a small a. That's fine because normally those two strings are considered different strings. But suppose I want keys to be case sensitive in this dictionary. I can achieve that by plugging in an appropriate equality comparer when I instantiate the dictionary. For example, as I've shown here, using the string comparer that does ordinal comparisons, ignoring the case. Now if I look up apple with a capital A in the dictionary, I expect that even if the key apple is there only in lowercase, it'll still be able to find it, because according to this comparer, case doesn't matter. But I'm only going to be able to find that lowercase apple if the hash code leads me to the same bucket that the lowercase apple is in. And that really means that apple with a capital A needs to give me the same hash code as lowercase apple. As we've seen, calling string.getHashCode won't do that, and that clearly means we can't use the default hash codes that string uses. And obviously the generalization of this idea is this: if any two values evaluate as being equal, then they must give the same hash code. And that really is an important requirement of hash codes. If you ever implement getHashCode in a way that breaks that requirement, any dictionaries that use your type won't work properly. That's why in all our demos in this course, whenever I overrode objects.equals, I made sure that I overrode objects.getHashCode too, to make sure that the hash code stayed in sync with what equality was doing. And that's also why iEqualityComparer of T exposes both an equals method and a getHashCode method. What actually happens with our example is that because the dictionary is using an equality comparer, in this case a case-insensitive string comparer, to determine whether the strings are equal, the dictionary will internally obtain hash codes by calling that same equality comparer's getHashCode method, not strings getHashCode method. And obviously the equality comparer's own getHashCode method will supply hash codes that are consistent with its case-sensitive equality, which means the dictionary will be able to work properly.